Hi there, and welcome to Leanne Arsenault's Math Learning Log. Throughout this video presentation, I hope to display my understanding of some math concepts introduced to me in Education 4050 class, and also model the methodology of ACT. ACT stands for Advanced Children's Thinking. Throughout this methodology, and as I hope to display in the video presentation, I will be eliciting, promoting many solutions for a problem, waiting and listening to the children's description of a problem and problem solving, encouraging elaboration, using students' thinking as a basis for a lesson, conveying an attitude of acceptance towards any errors and efforts that are made, promoting collaborative problem solving, and providing equal opportunity for all students to reflect. I also will be supporting the students by reminding them of similar problems and situations and encouraging use of prior knowledge, leading students in a recap of what they've learned, and offering and encouraging students to ask for help. I will also be extending, maintaining high standards for expectations for all, encouraging students to draw conclusions and generalizations, promoting reflection and push for alternative solutions to problems, but all while cultivating the love of a challenge. The purpose of the ACT methodology is to make math meaningful. It also serves as a compass to guide effective math instruction. So without further ado, let's act.
Wonderful mathematicians. This is my daughter Juliet, and this is my son Logan. Juliet's in grade 4 and Logan's in grade 6. So guys, you're helping Mommy out here in her math learning log, and what we're going to look at is the idea of the stable order principle, and that is that numbers counting sequence stays consistent, right?
Yes.
1, 2, 3, 4, and so forth. We're also going to look at the relationship of numbers, and to do that, we're going to work by doing a number line, okay? So remember what number lines are from way back? Yeah. Okay, so Logan, can you just draw a number line? Don't put any numbers on it. Just show me that you know what a number line looks like. And Juliet, what I want you to do is pick a number that's important to you, something that is important to you, a number that you like.
I think number 9 is important to me.
9?
Because I am 9.
Oh, because you are 9. Perfect. Okay, so let's look at our number line that Logan's drawn here. Now, if we were to look at the number 9, and let's say this number line starts at 1. So Logan, why don't you write a 1 here on top of our first notch there. Number line starts at 1. It doesn't matter anywhere you think. Okay, the number 1. And what number did you say, Juliet? 9? So let's go all the way in number line, all the way to number 10, because 10 is a great number, right? Do you agree 10 is a great number?
Yes.
Yeah.
And it's also an even number.
An even number, good. It's what we call a friendly number, right? Or the magic number, because we can do lots of good things with 10. Nice, friendly number to work with. Okay, so if we have a number line from 1 to 10, instead of putting 9 on it right away, I want you guys to show me where 5 would be on that number line from 1 to 10.
Right here, middle.
Okay, so you go ahead. Okay. Okay, Juliet, do you agree or disagree with Logan that that's where number 5 would be?
I think it would be a little bit more on this side.
Yeah. Is it kind of in the right spot
It
though?
would be like right here.
Yeah. Where would you say it needs to be though? Like a word to tell me where it needs to be.
Maybe like, do you know like this line right here?
Mm-hmm. Are you?
Maybe like in between that one.
Okay, you're pointing to the middle. Does it need to be in the middle?
No, not really.
No?
Yes.
Yeah, it needs to be in the middle?
But it doesn't have to be like exact, like the right
Okay.
point middle, but it kind of does have to be in the middle.
Okay. Logan, would you agree that it has to be in the middle?
Yes.
And why do you think that it would have to be in the middle?
Because it would just be lopsided. Because if 1's right here and 5 was right here,
If it was a scale,
there
it
would
would
be
be
like
weight
one
on one
row.
side and the other. If it was a scale,
Okay.
one weight on the other.
Okay.
One weight on the other side.
What is 5's relationship to 10?
it's you only need 5 more. So 5 plus 5 is 10.
Okay, so would you say 5 is half of 10? So it's probably a good idea
If we repeat
to put 5 in the middle, right? Because 5 is half of 10. So we know 1's here, 10's all the way down here, so 5 would be in the middle. So Juliet, if 5 is in the middle, where would you put, say, let's say the number 8. Getting close to our number 9 that we like so much. Where do you think number 8 would be?
probably right here.
Okay, you go ahead and write number 8. Logan, do you agree that number 8 should be there?
No,
Where do you think number 8 should be?
but right here.
Well, in the same area anyway, right?
The other
Yeah.
one.
Okay, good. Okay, so if 1 is here, 5 is in the middle, how do we know 8's on that end of the, like,
Because
Logan
it is
said?
close to 10 it rounds to 10. Does it
Good.
round?
How many more do we need to get to make 10 from 8?
2.
2. Okay. So let's see. Let's come back to this side here. Logan, can you show me where you think, just pointing where you think 3 might be on this side, or is it even on this side?
Should be right here.
Good. Okay, Julie, do you
Then
agree
4
or
would-
disagree?
4 would be right here. I agree, because
Agree?
2 would have been right here.
Okay.
And right,
4
it could
is
be
right
right here.
So what you're doing is thinking about 2's relationship to where 3 would end up, right? Because 2 and 3 have a relationship, right? Okay. So if I know 1 is here and 3 is here and 5 is here, where the heck would I put 6 and 7? Yeah, Logan, where would you put 6 and 7?
Yeah, but like,
Where would you put 6 and 7?
put 6 right here.
Mm-hmm.
And put 7 right here.
Okay. And Juliet, we're going to let you fill in where you think your magic number 9 would be. So what relation does 9 have to 10?
They're like buddies.
Okay, why are they buddies?
Because 9 is like right beside
It's not really
10.
buddies.
Right beside 10 or right before 10?
Yeah.
Yeah. So just looking at our number line, we've got 1, and where would we probably would put 2? Yeah. So you put 2 in. Nope, you're going the right way there. That's okay. Just put a 2. And then Logan can put 4 in, and then our number line will be complete, right?
Put it.
Oh, wait,
That's
hold
a
on.
2. It's
Hold on,
okay.
let me
It's
fix it.
okay.
I can just put it over here.
No, it's fine. We'll just leave it as is. It's more to show that you know the order of the numbers.
Yeah.
This stable order principle.
Which is
That
great.
2 is after 1, and 3 is after 2, and 4 is after 3.
Do you want me to circle
But before
the number?
5.
Magic number?
Okay,
Want me to
so
circle
that's great. No, we're all done. That's good. Good job, guys. Okay, guys, remember when we did our number line, we talked about 10 being a kind of magical number?
Yeah.
And we use it as a benchmark number because it's a nice, friendly, easy number to work with.
Yeah.
Okay, so I have something here today. This is called a math manipulative, and these are called. Does anybody know what these are called?
No.
Juliet, what's it called?
Counters?
Counters, or these are called 10 frames. So how many squares are in this? Can you tell from looking at that? Just quick, just shout it
10.
out. How do you know there's 10?
Because there's 5 on top and 5
5
on
and
bottom.
5. So So you have just done something called subitizing. You didn't stay there and count each individual box, or did you?
No.
You recognized immediately what? That 5 and 5, and 5 and 5 makes 10. So again, working with those friendly benchmark numbers of 5 and 10. Okay, so the game we're going to play, it's a challenging one, so I hope you're up for a challenge, but it's really going to test our subitizing ability, and subitizing means recognizing 10 right away, or recognizing groups of numbers that make up 10. So I'm going to give Juliet the green, so you can just go down to Juliet there, and Logan the red.
Thank you.
Your goal is to, as quickly as possible, and I'm going to time you to see how quickly you can do it, is to try and make 10. So Juliet's going to lay down a green piece of paper and a green 10 frame, and Logan has to match the red 10 frame that equals the magic number of 10. Okay? You can just ask. You don't put your hand up.
Can we show like an example of it?
Yeah. So if Juliet lays, how many have you laid down there, Juliet?
I laid 6, and if Logan lays 2, 4
Okay.
down, as he just did right there, we can make a match, and then we'll just put it off to the
No,
side.
you're going to leave it just lined up, just like that, okay? You're going to
So,
line them up
do
side
we
by
start at the
side.
end of the carpet?
Okay,
and
so
then
stack your papers, Logan. So just stack them in your hand, okay? You got to be able to flip through them quickly. That's part of the challenge, okay? All right? So I'm going to time you. Any questions? Do you understand what you're doing?
Yes. Yep.
Okay, so you're going to start up here and work your way down the carpet, okay? And you're working together, but the trick is you have to do it in complete silence as quickly as you can, okay?
Okay.
So zip those lips, and are you ready?
Yep.
On your mark, let's go. Awesome. Okay, good job, guys. Any ones you want to change? It took you 37 seconds. So is there anyone you want to change? Count 37 Mississippis it took you. So is there any ones you want to change before we check them?
Nope.
Okay.
Wait.
What are you thinking, Logan? What's caught your eye, Logan? Okay.
One of them is wrong with one, but I just kept it.
Okay.
Something caught my eye, and I'm like, what is it?
That's okay. All right. That's okay. Let's go through it quickly. So how many does this one have, Juliet? As quick as you can.
6.
And 6 plus, Logan? 4 gives you?
10.
Okay, next one.
2.
2 plus
8.
8 gives you?
10.
And the next one?
4 plus 6.
Gives me what, Juliet?
10.
Okay, now what if I go all the way down back to this one? So if this 4 plus this gives me 10, what if this 4? How many green do I need?
You need 6. This one?
Okay, if I put this one and this one together, does that give me 10, Juliet?
No. That gives you 8.
Right, and how do you know that?
Because 4 plus 4 is 8.
All right, so again, subitizing, not counting them individually, but recognizing that 4 and 4 in the 10 frame. Okay, that's great, guys. Good job. So I wanted to show you guys something else while we have our 10 frames out. You guys did a fantastic job of subitizing and making the magic number 10.
Okay.
Can't believe it only took you 37 Mississippis to do it. So, okay. So I wanted to show you something that you're probably already familiar with given that you're in grade 4 and 6, but just kind of remind you of something, activate prior knowledge. So if we have this, and these, we know that this plus this equals 10. What are the numbers we're working with?
4 and 7.
4 and 7. So 4 plus
No.
7.
6. 6. 1, 2, 3.
Oh yeah, 6, 6, 6, 6.
Okay, so
Dang it,
4.
I made a mistake.
Good. 4 plus 6 equals, what does that equal?
10.
10. Okay. Does this equal, what if we take it like this in our green? How many green do we have to start with?
7.
But
I mean,
it still
6,
equals
6.
the same.
Right.
Keep on making mistakes.
And that's the concept I'm kind of reminding you of, is this thing called cumulative property. So the old switcheroo that works in addition. So we know 4 plus 6 equals 10. So 6 plus 4 equals 10.
I forgot about that.
Yeah? You forgot about the switcheroo?
Yeah.
The other thing we can look at is what if we know that we have 10? So we know this equals 10. But we have the number, say, 3. So 3 plus what will give me 10?
Okay.
I know. 7.
7. Do you agree,
Finally.
Juliet? Do you
Can I
agree?
read it?
Yep.
Yep.
So that is called the part whole. So we know what the whole is. We know a part. And we need to define the other part to give us our whole again. So the part whole of looking at numbers. Do you think the switcheroo would work in subtraction?
Yeah.
Yes.
You think so?
No.
Yes.
No.
Okay. Logan, why do you think it would work in subtraction?
Can I have the
Mhm.
Let me just show you. Like, say that
No, it won't work.
1 minus 3. No. If I go. Let's just make this into a 9.
Okay, so 9 minus 3.
Would equal 6.
Okay.
No, it wouldn't work. That would be negative 6.
Hmm. So the old switcheroo doesn't work for subtraction, only
It
for
doesn't.
addition.
It doesn't work because look, 4 minus 6.
Can you do 4 minus 6?
No,
That'd
because
be
you'll have. Well, you can, but if you know your negatives.
Minus
Do you remember the old subtraction
0.
poem? If there's more on top,
cannot.
no
You
need to.
just stop.
And if there's more on the floor,
You need to go more.
you need to go next door, right? Okay, great job, guys.
6.
All right, now what we're going to do, my wonderful mathematicians, is we are going to remember back to grade 3, such a long time ago, and revisit the concept of place value. Okay? What does place value mean to you?
Hundreds, tens, and ones.
Hundreds, tens, and ones?
Well,
okay.
I'm learning place value in millions,
All right.
thousands,
Grade 6.
100, tens, and ones.
Okay. So when we look at place value, how do we view the number? Do we view the number as a whole number?
Yes.
Okay, can you tell me a bit about that?
Because if like you put like a 1 in the 100, a 2 in the 200, a 3 to 300, 123,
Okay.
103, 103, and that's it.
So let's stick with that. So if you put a 1 in the hundreds column, and what did you say?
2 and a 10,
Okay.
3 and a 1.
Okay, so what does that 1 in the 100s column represent?
1 in the hundreds.
Oh, it represents 100. What does the 2 in the tens column represent?
20.
Okay, so 2 sets of 10, right? And what does the
3.
3 in the ones column represent?
3.
Represents 3. Very good. Julia, do you agree with that? Were you following along with that? Pretty good?
Yep.
Okay.
But
So,
the only problem is you should always start as ones because
if it equals more than 1, you go to 10. So if it equals more, then you should go to 100.
Right, so once I hit 9 in the ones, what is that?
9 in the
Okay.
1s.
So if I get 9 in the ones column, what do I have to do next? What do I do if I hit a 10 in the ones column? What is it?
You would have to knock next door, and next door would take that 10.
Okay.
And if you had 10, you would put the 0 here. And then if there was 3 in here, there would be 4.
Okay.
And it can't go over, let's say, 100.
Mhm.
So now we're going the hundreds column. But if you have 100 in it, and 100, and this has 100, this 100 would keep the 10.
Well, that's an adding. It is place value.
Mhm.
That's adding and subtracting. Do place value.
Yeah. So place value is just once you hit 99. Well, let's look at it with our hundreds chart. If we come over here, and the 100 chart is kind of a chart in progress here. But once we hit 99, what happens to that number?
Goes to 100.
It goes to 100. Does that stay? Does that 100 still represent? Does that 100 still represent for us
100?
in the tens column, like the 99 would, like the 90 would?
Well, this is the tens column.
Yeah, you're right. On a hundreds chart, that is. But I'm coming back to our place value. Once we hit 99, do we still stay in our tens column?
No.
No. Where do we go to now?
You would go
Triple
to your
digits.
hundreds. And then
Triple
you
digits,
go to
except for
100.
Yeah,
So
we don't
you're
have
going
any
to
base
10.
10 blocks to show it, but remember back to base 10 blocks when you were looking at that, you would look at the base 10 blocks and you would see that a flat equals how much?
100
100. And
cube.
an individual cube would equal what?
1.
And a rod would equal how much, Julia?
10.
So if I had 10 rods, how many would I have?
You would
What would it be the same? Would be the same as 100.
And
same as a
100
flat.
ones would equal 100, of course.
Of course, absolutely. So it's just kind of looking at that.
Oh yeah, and also the big cube is 1,000.
Yeah, right. Yeah. So it's looking at unitizing, the ability to think of a single unit within a group of 10, right? Yeah. Okay, so we're going to introduce you to this quick game. We're only going to play a couple rounds. So basically, the idea is to get the biggest number, okay? So we're going to see who can get the biggest number.
Can I go first?
There's
Yeah.
no prizes.
Logan can go first.
Got my card, so I'm gonna put a.
So nice and loud so we can hear you.
I got a 3, so I'm gonna put the 3 in the ones like I did in my example.
So that 3 represents what?
3 ones.
Okay, Julie, go ahead.
4. I'm going to put it here.
So what does that 4 represent now that you've put it
40.
in? 40, good. And I've got a 7. I think I'm going to put that 7 in my hundreds column. So that represents what now?
700.
700. Okay, go ahead, Logan.
Put this in the 10.
Nice and loud so we can
I'm
see.
gonna put 6 and 10.
Okay, and what does that represent?
60.
So what number do you have on your paper right now?
63.
Awesome. Juliet, go ahead.
3. I have 43.
43, put it in the ones. Okay. I have a 6. I'm going to put that in my tens column. So I now have what on my paper?
706. 760.
Juliet, do you agree? 760? Good. Okay.
Ooh, 9. I got a 9 and I put it in the hundreds. So I got 900. 963.
Awesome.
2.
2. And you look a little bit upset. Why are you upset? What does that
Because
mean?
I got the lowest number.
And how do you know that?
Because I only have 200 and Mom has 700 and Logan has 900.
Okay. And I have an 8. So I have 768.
Oh, wait, I just noticed
So
that one.
7 100s,
Mhm.
6 10s, so 60,
Yeah.
and
60.
8 ones is 8.
768.
So who's the winner here, guys?
Me.
With what number?
963.
Awesome. Good job. math learning log was talk to you about distributed property. So it's basically taking a large number and breaking it down into more friendly numbers to get the whole number again to count. So I'm just gonna make up a scenario here with these lovely colored building blocks. So I was given these building blocks by the next door neighbor, and he really needs to know as quick as possible how many blocks are in this bucket so that he can give them to a friend of his, say, okay? So he asked me to count them as quick as I can and get back to him because he's waiting at the door now to get it. But the problem is there's a lot here, right? And for me to count each one individually, there's lots of different shapes and colors, I might get mixed up. So how about we work together and we group them to help us take this large number of building blocks and break it down into simpler so we can group, so we can, something called distributed property, break it down so we can count them quicker and give him an answer as soon as we can, okay? So I'm just gonna dump them out and you guys can start grouping and counting, okay? Okay, Juliet, let's get counting.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey.
Okay, he's really waiting for us here. Let's get going. What do we have? Wait, no,
Hey,
Logan, you're taking
stop.
her pile.
Okay, I'm stuck with my tile.
I'm done.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1,
Okay,
2,
so Logan, quickly tell him how many you have on your side.
So if I do 5, 10, 15, 20, 25, 30, I get 30.
Okay, so what was your strategy that you used? to
I
count them?
made groups of 5,
Groups of 5. You group them into 5.
and it was very quick.
Okay, so you have 30. Okay, Julia.
I have 24.
Okay, and what was your strategy for counting them out?
So each pile has 10 in it,
10. Okay.
and every time when there's a 10, I'd put it into a pile, and when I didn't have 10 left, I would just count those
Okay.
as ones.
So how many do you have altogether then?
For me and Logan, so just mine.
Nope, just yours.
I have 25. No, 24.
Okay.
So we have 54 together.
Do you want to double check that again?
Yeah, because 30 plus 20, 30 plus
Yeah.
20 equals 50, and it's just 4 remaining, so
Good. So you broke it down to make it easier numbers to deal with, and then simply counting out the individual. Okay, but actually, oh, that is 1 because I thought that was 2. You're right. It is 4. Okay. All right. Good. So good strategy, breaking down, breaking apart, so we can let our neighbor know that there are how many?
54.
54 blocks, and we figured it out like that. Awesome. Good job, guys.
Cut.
Hi there. So we've lost one of our mathematicians. She's actually gone to bed. So my night owl is going to help me with one last concept for this math learning log entry, and that is the idea of compensation. So Logan will demonstrate that to us, hopefully. I'm going to give you a word problem, and what's going to happen is you're going to show me what you have to do with the manipulatives here to solve the word problem too, okay?
Okay.
So I went to the craft store to get some cones and cylinders today to bake a craft for Thanksgiving, okay? And when I was there, they said that I could only buy 7 total because they're really low in stock, okay? Problem is, I need help to decide. There's 10 to choose from. What can I do? What if I decide I want 4 cones? You show me 4 cones? I'm only allowed to buy 7 total of the products they have on the shelf. So how many cylinders can I add to those 4 cones to get 7?
3.
Okay, does that give me 7?
Yes.
Okay. I changed my mind. I'm really interested in the cones, so I think I'd like to add another cone. So what do I have to do? Why did you do that?
Because you're only allowed 7. 5 plus 2 equals 7.
Okay.
But if I kept this one in, it would equal 8, and that's over the limit of
And
how
I'd
much.
be in trouble,
And
right?
you'd be in bad trouble.
Yeah, because I was over the limit.
Yes.
Actually changed my mind. The cylinders are kind of neat. I can make some cool stuff with that. So I think I want 5 cylinders now.
So take 5 cylinders, and you take away 3. So all of them that you're I got an idea to show you how to do it. So say that you have 2 and 5, and you want to add 1. You gotta take away one of the other kind.
That's exactly it.
Then you put another one. You gotta take away another one.
Yay! I saw the light bulb go off. So that is called compensation. Whatever you do to one side, you do the opposite to the other side. So for example, if you add to this side, you have to
Subtract,
take away.
subtract from the other side.
Right, to compensate.
Yes.
Awesome job.